All right, today we're going to be talking about perpendicular equations through a point. So with perpendicular equations, again, we have to do something to the slope to make it perpendicular. So if this is my original equation, my original slope is 1 over 5. So to make it perpendicular, I have to flip the fraction and then change the sign. So when I flip that fraction, change the sign, it's going to become negative 5 over 1, or just negative 5. So I know this much of the perpendicular equation is going to be y equals negative 5 x, but what I don't know is the specific y-intercept of the perpendicular equation that goes through this point, just like with the parallel lines. So I have to put in plus b there, and then I have to solve for that y-intercept. To do that, again, I plug in the coordinates I know. So I know at some point this line is going to go through this point, so I know at some point x is going to equal 3 and y is going to equal negative 1. So I'm just going to replace those with those coordinates. So negative 1 is equal to negative 5 times 3, and then plus b. Negative 5 times 3 is going to be negative 15, so you get negative 1 is equal to negative 15, and then plus b. And then last step, solve for b, you would have to add 15 to each side, and cancel that there. Negative 1 plus 15 is going to be 14. So b is equal to 14. Now this is where most students make the mistake with perpendicular line equations. They're going to take this b and replace it with the original y-intercept, but that's not right, because, oh man, because that is the original line, so if I did that, it would be a parallel equation. I want a perpendicular equation. So remember, the b is going to come up and replace the first equation that you, or the first b that you started with. Okay? So when you plug this back into your original perpendicular equation, your final answer is going to be y equals negative 5x plus 14. Okay? Let's do one more example where we have to solve. So let's just do this one right here. So looking at number 5, this one I can't actually see the slope yet, so again I have to put it in the slope-intercept form, which means the y has to be by itself. Again, you treat it like a party problem. Get rid of your acquaintance first, then your best friend. So to get rid of that x, you'd have to minus it to both sides, cancels out there, and you're left with 4y is equal to, and I'm going to move this in front of that positive 32, so it stays in the form you guys are familiar with. So 4y is equal to negative x plus 32. Then I would divide by 4, divide by 4, divide by 4, cancels out there. Y is going to equal negative x over 4, the same as saying negative 1 over 4, x, and then plus 8. But again, that doesn't really matter. What matters is the slope. So this is my original slope. Okay? Now I want the perpendicular slope to it. So I've got to flip it and change the sign. So it's negative 1 over 4. So when you flip it, it's going to become positive 4 over 1, or just 4. So I know this much of the perpendicular equation. It's going to be y equals 4x plus b. So again, I'm going to plug in my coordinates. So I know this is the x, this is the y. So this is going to replace the x, this is going to replace the y. So I'd get 1 is equal to 4 times negative 5 plus b. 4 times negative 5 is going to be negative 20. Okay, then to solve for b, I need to add the 20. And b is going to equal 21. So then, last thing we're going to do is I'm going to take that and replace the b in that first equation I started with. So your final answer is going to be y equals 4x plus 21. Okay.